switching it until I reach the end.
Okay.
So I find zero. I see the next one is not a zero, so I switch to zero,
Mm-hmm.
and then I keep doing that until I reach. I think do I keep doing that until I reach another zero or until I reach the end? I think I think I do it. I keep doing it until I reach another zero.
Yep.
Yeah.
Okay.
So I think but that's still. I think that's n log n, or is that n squared?
Um, you give it a try and then we can see how that goes.
Yeah. Yeah. But I feel like that's a naive solution. I don't I don't think that's the most optimal way to do it. I think there might be a better way. So um, another way to do it is actually using another data structure. So I can use like another array, so ARR two,
Mm-hmm.
and in this array, so I can loop through the first array and just keep putting. I can just keep putting the ones that aren't zeros. So
Yeah.
1, 10, 2, and I keep going until what? And then there's 8, 3, 6, 4, 5, 7, uh,
Mm-hmm.
5, 5. And then I know that the remaining elements have to be zero, so I just fill in the rest with zeros.
Yeah. That
That's
that
that's
that
O
works.
that's O of n space complexity though, but it's also O of n time complexity.
Yeah.
So so I don't know if there's a solution with O of n time complexity and O of one space complexity
Mm-hmm.
where I don't have to use a separate data structure, but I'm just gonna implement this and see how it goes.
Okay. Yeah. Sounds good.
Equals new int. So initializing a new array to the same length as the
Mm-hmm.
previous one. Go through the previous one, and the default values are already zero, so I don't have to change at the end.
Okay.
So I have less than arr dot length I plus plus, and I should also keep a counter in my current array. So int um, current counter. This tells me where I need to place the next element in the array. So
Okay.
first is zero. So if arr I is equal to or is not equal to zero,
Mm-hmm.
then arr two current counter is equal to arr I, and then current counter plus plus. Okay,
Okay.
and then I think that should just return the correct answer. I'm just running it first and seeing if it compiles, and then I'll run the test cases.
I guess you have to,
Okay.
yeah, provide
Yeah,
it with the array.
yeah, okay. They all passed,
Yeah. Cool.
but so I'm thinking there could be a way to do it in O of n
Mm-hmm.
in O of n space complexity. I
Um,
mean O of one space complexity.
yeah. So you can do that with O of n sorry, O of one space complexity, but like the first approach that you told me, where you are just swapping
Yeah,
the elements. So why
yeah,
don't
yeah.
you have a pointer?
You want me to try that too?
No, so
Oh,
I was saying that have a
okay,
pointer
okay.
and then make that like
I get
you go on.
I get it.
Yeah.
So so I should also maybe have a pointer that tells me when to stop, right? So so
Mm,
I have a so so I have an end pointer is equal to the at the end pointer is equal to the first element that isn't zero from the end. So so in this case it would equal to 7, right? So then I go through the array, find the zero. I keep swapping until I reach the end pointer, and then I decrement the end pointer by 1. So now the end pointer is here.
hmm. So how
I
many
think that
loops
works.
will you require for that? Like, just one loop,
Uh,
or how many?
oh, you're right.
N
That's
square,
that's
right?
two loops. That's n squared.
Yeah.
So so you said to do the first thing I said, right?
So
But that's also
yeah, what I meant by that is whenever you uh, see a non-zero, basically a non-zero element,
yeah.
you swap it with that pointer that you are keeping track, and then you move that pointer uh, along the way, and as soon as you spot a zero, uh, let's say you will stop that pointer, and
Oh,
when you see another element, like which is not zero, obviously you'll swap it at
I get
that
it. Yeah.
place. So it's
Yeah, yeah.
basically will be running in of n time
Yeah.
complexity.
I get it now. Yeah,
Yeah,
I see what you're saying. I'll try to implement that.
yeah,
So, in actually, I'll just comment out this code.
yeah.
And then, okay, so int pointer one equals zero. Okay, so
So just dry run through it first, instead of
yeah, yeah,
jumping to the solution.
yeah.
Just
True,
dry run
true.
through it
Okay,
and see if
so
how that works. Yep.
I have two pointers. Um, one pointer makes sure I stop at zeros, and one pointer keeps going. So if I get a non-zero element, I keep going. If I and then until I find a zero element. Once I
Yeah.
find a zero element, my first pointer stops. My second pointer keeps going until I find another non-zero element.
Mm-hmm.
And then I switch the non-zero element with the zero pointer element, and I move the zero pointer element forward.
Yeah.
Yeah. Okay. All right. I think I get how to do this.
Okay. So yeah, that's a trick of doing this question, but yeah.
Yeah, that makes sense. Um, so while pointer two is less than that. Okay. So if ARR point or okay, um, pointer one plus plus. Okay, so if the first pointer is not equal to zero, then I increment it. If it is equal to zero, so um, else if ARR pointer two is not equal to zero, I swap. So ARR, so I'll just have a temp in temp is equal to ARR. Hello?
Hello. Yeah.
Yeah,
I'm
yeah,
still here.
okay. Yeah, yeah. So and then ARR pointer one is equal to point. Okay, so
Mm-hmm.
and then pointer two increases regardless.
Yeah.
Okay, and then pointer one plus plus.
So what's can you please explain me what's going on here? Like the first
Yeah, yeah.
20 line number 22.
Line 22. Okay, yeah. So pretty much, while my second pointer is less than the length of the array,
Mm-hmm.
uh, that's my loop. And then, so first I check if my first pointer is, if it's not equal to zero, I know that I don't have to swap or I don't
Mm-hmm.
have to stay there. So then I move it forward. If it
Okay.
is equal to zero, if it is equal to zero, then I check if the second pointer is at an element that is not equal to zero. So it's at a non-zero element. So then if it is, I can swap. So
Okay.
then I swap the first pointer or the value of the array at the first pointer with the value of the array at the second pointer, and then I increment pointer one.
Mm-hmm.
Yeah. So I think, and then yeah, that keeps going.
Okay.
Uh, I think this works.
Okay.
So
Let's see. Yeah.
um um oh yeah, run test.
Oh,
Yeah,
cool.
works.
Yep.
Okay, that
That.
makes sense.
Yep.
Yeah,
So
I've seen
it's
the algorithm before. I don't know why I didn't think of it. Yeah,
yeah, it's a trick, but yeah, good
yeah.
job there. Okay.
Any advice?
Um, y- yeah, like your thought process is on point. I'll rather say that rather than just jumping. That's what I observe. You directly jumped onto the coding. Instead, like take your time, explain through the process. I
Okay,
guess that's what the rule book says. I don't know. Like
got it.
on the day of the interview, what happens? It
Which
happens.
is
So
today.
yeah,
Yeah,
you have interview today.
yeah,
Oh, all the best about,
at 4.
for that.
Yeah, yeah, yeah.
Okay.
Good communication, or did I
Uh,
have good communication?
yeah, your communication is on point. As I said, like just take your
Yeah.
time, explain through, like dry run through it. Uh, don't rush through it. Take your time. You know your
Okay.
stuff. I can see that. So,
Yeah,
uh,
that makes sense.
yeah, cool. That's
Okay.
what I'll say. We all make mistakes. It's okay. So,
Yeah, yeah.
should
Great.
we swap the roles or?
Yeah, we can swap roles. Yeah.
Okay, cool.
Oh, okay. You can click it. You can click it.
Sorry.
Yeah. No, no, no problem.
Okay, so I'll just read through the question. Array
Yeah.
index and element equality. Okay, so given a sorted array of distinct integers, write a function index equals value search. Okay, that returns the lowest index I for which array of I equal to I. Return -1 if there is no such index. Analyze the time and space complexity of solution and explain its correctness. Okay, given a sorted array of distinct integer, it's sorted. Write a function index equals value search. Return the lowest index I for which array of I. Okay, got it. So yeah, basically, what I understand from this question is that they are looking for a value which is equal to its index
Yeah.
and its lowest, right?
Yes.
So, why don't we just so first intuition that comes to my mind is intuitive thought is like why don't we just do a linear search element by element and check its index as they are sorted, so that would be uh, of n time, and so let's say we have this -8 0 2 5, so 0 1 2, yeah, so I guess that's what makes sense to me, like first intuitive thought, but we have given that everything is distinct and nothing will be repeated and it's also sorted. So when things are sorted, it's usually a good idea to use a binary search. um, so let's say I have the length of the array and I can go to the mid, and what I have to check is if mid is equal to its index, like the value at that mid. If not, then it will be either on the left or right. So yeah, we can definitely use binary search here. So brute force would be linear, and log n time complexity would be our binary search. So that's what it will be. And if we are not able to find it, yeah, definitely we can just return -1. So I'll
So
yeah.
I was gonna say, can you explain? You explain binary search. Can you explain what to do if the current value that you're checking is not equal to uh, the or is not does not match the condition that the index is equal to the value. In that case, how do you decide where to move your pointer?
Yeah, where to move that. So that's interesting. So I am thinking, let's say, uh, let me do some dry run through this. So binary search are kind of, they are tricky in terms of the boundaries that they have. So 1 2 3, okay, so I have this. So let's say the length is 4, right? So 4, I'll get the mid here. So 0, I'll see 0 and 1. Okay. So here, in terms of that, we don't have a target that we are looking for, right? So yeah, that does make sense. And then so 0 and 1. So basically, it means that we don't have uh, yeah. So what I'm thinking is, if at any given index, um, the value is less than the index, um, that yeah, that does make sense. If it is less than the index that we are on, uh, that means we have some negative values, as in this case there are. Then obviously that portion won't be sorted, like we won't find our guy there in that portion. So in that case, we should shift our pointer to the left pointer should go to the mid, and we should start searching in the right side. Does that make sense?
Yeah, that makes sense.
Yeah, thanks for asking that question, because I would have started coding and I would have stumbled upon this situation. But yeah,
Yeah, no problem.
uh, that does make sense to me. I might be missing some. So let me check first. What is the length of the array? It's 100. Okay, and I am having negative and positive integers. Everything is sorted. So I think I have a good understanding of what question is asking. I might be missing something, but let's
Yeah,
let's say,
go ahead and start coding.
yeah, I'll do that. So I'll have my left pointer 0 and right pointer array dot length -1. So yeah, that's what it is. Then while left is less than equal to right, I will be doing this. And yeah, so I have to find the mid, which is math dot floor, and right plus left. Okay, I need to put this in the bracket by 2. Yeah, so if I do that, I'll get the mid. And then I just need to check if mid is equal to, oh sorry, array of mid. And yeah, that does make sense. Then I'll return the mid or anything, right? And if I can't find anything, uh, even after my left and right pointer shifts, like, then I'll straight away return -1 in the end. And here's the tricky part, where we'll check if mid, the index, is where was I? Yeah, if index is greater than the value that it has, um, so nums of mid, right? So I know from this I can recognize that okay, so if it is greater, then I have to shift my pointer to left as we discussed. So left is equal to mid plus 1, and else right is equal to mid minus 1. Let me just see if this works. So I'm here, I come to 0, then yeah, so I go here, and then this guy. Okay, I guess this should work, but I'm not sure. Let's try to, I'll just
Yeah.
get this array and try to console log it and see if that works. um, so let r is equal to this guy, and so if mid nums. Oh,
Keep it
did I
keep it
write
nums. Yeah.
nums? Okay,
Yeah.
god, I'm used to writing nums, so log
Yeah.
of
I
two.
am too.
So yeah, we got two. So that does make sense, but let's see if we can't find anything. um, that's r is equal to, okay, okay, minus 1. So it's passing. So should we run this out?
Yeah. Run test.
Okay, cool. Oh, cool. We passed
Also,
it.
uh, I I think there's a for some reason their test cases don't account for edge cases, but there's some edge cases you didn't account for.
Okay.
So let's say I have indexes 0, 1, 2, 3, 4, obviously, right?
Mm-hmm.
And let's say I have numbers 0, 1,
1 2.
2, 3, 4. So what will your program output in this case?
um so let's say we are doing the same thing, then it's a length 5 will come here. Oh yeah, that does make sense. Will be lowest one we have to find, right?
Yeah.
So in this case, so what we can do is, before we start, like the operation, we can just check the first, uh, if the first character is sorted, like if it is the lowest one, then we can probably return that as an answer. So that would take care of this edge case. But there are there any edge case that
There's more. Like
okay.
if let's say so you're saying return just check if 0 is equal to 0 and then return 0, right?
mm, yeah, basically,
Yeah.
yeah, that's what I said.
So then what if I have this?
Minus 1. Yeah, yeah. So in that case, if this algorithm, yeah, then this doesn't make sense. So the linear search one would be a good approach, but yeah, this is a
You,
good
you,
good
you,
one.
yeah. You can still do it in binary search. I'm just telling you. There's
Okay.
a small little implementation you need to add, but that's
Mm-hmm.
all.
Okay. 0.
So,
Okay, minus. Yeah, that's a good one. 0 1 2 3 4. Okay. So what am I not accounting here? So I come to 2, then I see that 2 is equal to 2. So instead, okay. Um, what I can do is, let's see. I'm thinking of keeping a uh, min value, which will be what? Which would be -1 uh, initially, and then like I'm just thinking like when I find the mid, I'll just update that min value, or let's say I have, so this length is 100, right? And so integers can range to in minus infinity to infinity is.
Um, I think yeah, that's what you should. Well, I mean, it's integer, so
Yeah,
the max integer value.
okay, so safe integer, so this gives us that. Yeah, if let's say we find a match by doing this, then we compare the minimum value and update it, obviously. And okay, so but I'm just thinking, instead of returning mid, so what I did here was mid if mid is greater than array of mid. Hmm. Then we started shifting our search. But if everything is sorted as you said, um, then what should we do? Should we, yeah, we should be going to the left, as the value to the right would be obviously greater. So if I find, okay, yeah, I can definitely uh, keep this in else if. I'm thinking of keeping this in else if, and uh, shift my um, right pointer to mid and keep my left pointer as is. And so I'm thinking of shift the right pointer here,
Yeah.
and so yeah, what I said was I'll also do mat.min, whatever the minimum value is, min value and min, right? So I'll be doing that and I won't be returning anything here. So, and min value would be this, yeah. And up, update min value, and shift right pointer right should be mid -1. Yeah, I should be doing that. And I updated this guy, and I have to return the min value. If min
Yeah.
value is, sorry, my camera just died.
That's fine.
Yeah, it's back. So if my min value is, let me copy this integer and let's paste it here. Let inf is equal to this, so that I don't have to write that big line again and again. So if my uh, minimum value, let's say, because if my minimum value hasn't changed at all, so that means it's -1, or else
Yeah.
it's min value. um, I hope this should work. Oh, sorry. Yeah, let's put this guy in an array. So is this question available on lead code, or how is it like?
I've never seen this on Leak code, but
Oh, okay.
I'm not sure.
um Oops, sorry, my bad. I shouldn't have commented this out. And comment this out.
So the answer should be 1. Oh,
Okay, I might have min value, min matter. Oh, so it should be mid. Yeah, yeah,
yeah.
1.
Okay. Yeah. All right.
So
That's good.
I'll just run the test cases. Yeah, it passed. Oh, thanks, buddy. I kind of missed that. That's a good catch.
No, no problem. They should have test cases that show that. I don't know why they don't have any cases like that. That's a bit weird.
Yeah, but were you able to solve this question as in when it appeared, or like how did you get to know that this might be the edge case?
Yeah, actually, so when I when I first encountered the question, uh, I did this question previously on another interview.
Oh,
So
okay,
yeah, so I did the same thing you did. I didn't account for the edge case.
okay,
Uh, and then I think my interviewer also told me like about the edge case. So
okay,
then I solved it the same way you did.
okay, got it. It's pretty
Yeah,
good question to be asked in an interview. Like,
yeah, yeah,
you really get to know if they are thinking about the edge cases and if they are able to, once we tell them, give the hint that you can do it, then if
yeah,
they
yeah.
are able to solve, come up with the actual solution. But yeah, I won't take your much time. I know you have an interview.
Oh
Um,
yeah, no problem.
yeah. All the best for your interview, and hopefully you crack it. Is this
Yeah,
a?
thanks.
I won't ask much. Yeah. Uh, I was going to ask like if this is the first round or last round.
Oh, this is first round. Yeah,
Okay.
first technical interview. Yeah.
Okay. Okay. All the best, man.
It's the first technical interview I've ever had. So
The one that you're going to have.
yeah, yeah, yeah.
Oh. Okay.
I haven't
Okay.
had a technical interview before, so I'm kind of nervous, but I'm just hoping for all the best.
Yeah. Just relax. It's okay. Like
Yeah,
either you're going to solve it, or you just try to be yourself and try to walk through the solution. Yeah, like at the end they can give us anything, right? So
yeah,
we just have to use, you know your stuff. I can see that, so that's all I can say.
yeah.
Okay.
All right.
uh,
Yeah.
be
All right.
yourself, and
Yeah, yeah.
you'll do it.
Thank you. Thank you. I appreciate it.
Yeah, thanks,
All right.
buddy.
Bye. Have a good day.
Yeah, you too, take care, bye. Yeah, so why don't this is showing up? Okay. Hopefully that was an amazing that was a nice experience for you all. That was in fact a good coding question that I've had in a long time. uh, because I was getting coding questions that I've already seen, and not something that I haven't done before. So this one was a really good question. um, and yeah, I was not asking anything to the interviewer because I don't want to, that I have a kind of superstition. I don't want to jinx it or anything, so uh, I didn't uh, bother him with my questions. Hopefully, I was calm and I solved the question in a good way, explaining my approach. And please let me know if you think I should improve in some or the other way. And yeah, if you like this video, and uh, if you like this video, what I'm doing, please like the video. I This is the first time I'm asking for liking this video, but seeing the stats of my videos, uh, yeah, it's really fun. So if you like the video, then like it. I would really appreciate it. Thank you so much for watching. um, See you in the next interview or a stream. Till then, take care. Peace out.